second day. And so we've got three things we need to cover. We need to cover the product and quotient of two complex numbers. We're going to cover De Moivre's theorem, and then we're going to cover the nth-roots theorem. And so first of all, the product or quotient of two complex numbers. This is really easy. All this is saying is that you have two numbers, right? Okay. The first one is z equals r1 cis 0, or theta 1. And then the next one is z sub 2 equals r sub 2 cis theta sub 2. Okay, now these are just complex numbers. That's all they are. That's what that cis means. Okay, this cis right here, that just means it's a complex number. And so if I want to find the product of these two complex numbers, which is in fact what you had on your homework, all you're going to do is you're going to multiply the r's and you're going to add the angles. That's all you're going to do. So if you had two complex numbers, example, maybe you had 3 cis 60 degrees, and let's go 4 cis 10 degrees. The product of those would be 12 cis 70. That's all you do. Now when you divide, what you do with the radii is you divide the radii and then you subtract the angles. So in this case it would be 3/4 cis 50. So that's all you have to do. Pretty straightforward. So now what we're going to do is we're going to talk about De Moivre's theorem. Now you don't need to write this down. This is just a little history lesson. Here we go. And Abraham de Moivre, notice when he lived from 1667 until 1754. He was a French mathematician. He was good friends with Edmund Halley, Halley's Comet, and Sir Isaac Newton. In 1707, so when he was 40 years old, he published a paper in which this theorem was first printed. De Moivre's theorem helped to develop complex number theory, which in fact in most colleges they offer complex numbers as a class. I did in fact take that class in college. De Moivre lived in poverty. He earned a meager living by privately tutoring students in mathematics. He tried numerous attempts to become a college professor to no avail. De Moivre is probably best known for predicting the day of his own death. He used arithmetic progression, and what he was noticing is that he was sleeping longer every day, every night. And so what he did is use that arithmetic progression to find the exact day that he would sleep for 24 hours. So kind of interesting. He's actually had it written down and published them. So let's go ahead and talk about what De Moivre's theorem is. It's used to find the power of a complex number written in trigonometric form. So if z equals r cis theta, remember, r cis theta, this is nothing more than a complex number. Another way to write a complex number, because up until this point we've been putting r comma theta. Now what we're going to do is this is just r cis theta. Okay. How you find the power is you take the radius times whatever the power is, and then you multiply the angle. So if z equals r cis theta, then z to the n equals r to the n cis n theta. Now notice, this is what, there is a little note down here. You might want to pay attention to this. If a complex number is written in standard form, now when we say standard form, that's like your a plus bi. You're going to want to use FOIL to find the power instead. Okay, reason being, what you would end up having to do is convert it to the r cis theta form. And so it's almost faster for you to just go ahead and multiply this out. So notice, if you are given z equals 3 plus 4i and you want to find z squared, you just multiply the two. That would be a lot faster than using De Moivre's theorem. So what we're going to do is we're going to go ahead and look at an example of using De Moivre's theorem. And let's look at this. It says, find each power and express it in rectangular form. Find each power and express it in rectangular form. So there are two ways to do this. The first way is I could go ahead and write out 4, 1 plus root 3i, 1 plus root 3i, 1 plus root 3i, 1 plus root 3i, and multiply them all out. That's an option. Or what I can do is do de Moivre's theorem. So how I would find de Moivre's theorem is, first of all, I'm going to plot that complex number. And we learned that 1 plus root 3i means I'm going to go over 1, and I'm going to go up root 3. And so really, the complex number is going to be right here. What's my radius going to be, or the hypotenuse there going to be? Oh, come on. 1 root 3, it's a special triangle. 2. Yes. What's your angle here going to be? 60. So really, this I could write as 2 cis 60 degrees. Okay, remember that cis just means it's a complex number. Now what I'm going to do is I'm going to take that to the 4th power. So what exactly does that mean? That means you're going to take 2 to the 4th power, cis 60 degrees times 4. So I know that sounds kind of weird because you would think that you would take 60 to the 4th power too, but you don't. You just take 60 times 4. So 2 to the 4th I know is 16. Okay. Cis, what's my angle going to be? 240. Now that's in polar form. What they want to do is they want us to actually write that in rectangular form. So rectangular form is exactly what I started with. So in order to write that in rectangular form, 240 degrees is going to put me right here, right? That's where 240 is. I know I've got a radius of 16. So let's go ahead and locate what I end up having here. What type of angle here do I have? What angle will be right here? Try again. 60, so it's a special triangle, right? So if 16 is my hypotenuse here, what will the side opposite the 30 be? 8. What will the side here be? 8 root 3. Now notice where those are located. What can you tell me about the 8? It's negative, and the 8 root 3 is negative. So if I'm going to go ahead and write this in polar form, I get negative 8 minus 8 root 3i. Things I'm going to be looking for, I'm going to be looking for the 16 cis 240. Okay, so if you make a mistake in the conversion, it's going to be minimal. Let's go ahead and look at another one. Okay, find each power and express it in rectangular form. This is actually really easy. Okay, it's just like the problem we got done looking at. Okay, I could go ahead and do what Ross already suggested. Ross said that cosine of pi over 4 is root 2 over 2, and sine of pi over 4 is root 2 over 2. So now if I go ahead and distribute, which is what was suggested then by Christina, if you take 2 times root 2 over 2, you get root 2 plus root 2i, and I want to take that to the 4th power. So once again, if you don't like what we just got done doing, you could go ahead and take root 2 plus root 2i and multiply it out 4 times. So what do you want to do? Do you want to do that, or do you want to go ahead and draw it in like we did? Okay, so what I end up having here is root 2 plus root 2i. Means you're going to go over root 2 and up root 2. What's my angle going to be, since I already know you know this? Angle? 45. Good. Okay, and what's my hypotenuse going to be? Yes, you're right too. So really, once again, if you didn't know that, you can use the Pythagorean theorem. You get 2 cis 45 degrees. Real quick, for those of you that are kind of wondering where the 45 come from. How did I know that was 45? The two sides are the same, so it's got to be 45, 45, 90 triangle. Let's go ahead and apply our power. I get 2 to the 4th. Cis, 45 times 4. So what's 2 to the 4th? 16. Cis, what's my angle? 180 degrees. Where's the 180 degrees? On the line. So what that means is I've got a point over here, because there's 16 cis 180. And what is the value at this point? 16, right? Because that's what my radius is. When I open up to 180 degrees, this distance here is my radius. It's got to be 16. And so if I were going to write that in rectangular form, it's going to be 16 plus how many I? 0, because it's not going up. Or 16 would just be my answer. So that's de Moivre's theorem in a nutshell. Questions? Oh, skipped it. The last thing we're going to talk about is the nth roots. So this means instead of taking a power, you're actually going to take a root. So instead of raising it to the 4th power, you're going to raise it to the 1/4 power. Okay. So if you notice here, okay, it looks similar to de Moivre's theorem, except for there's one big addition. Okay, here's your big addition. 4 n equals. Okay. Oh, not 0. Take that back. What was I writing 0 for? 1, 2, 3. I wrote that wrong. It's k, n minus 1. This has got to be k, sorry. There we go. For k equals 1, 2, 3, up until n minus 1. So what's going to happen is you're going to have multiple answers on this one. You got it written down? Ready to go? So let's go and look at the next one. Find the 6th roots of I. So the first thing I need to do is I need to put this in polar form. So if I just want to plot 1I, where's 1I going to be? Where? On the line? Yep, straight. So this is where 1I would be located. Right? This is where 1I is. So what is my radius going to be there? Radius is going to be what? 1 cis, what's my angle? 90. So there's my power. Now what I'm going to do on that power is I want to raise it to the 1/6 power. Okay? I want to raise it to the 1/6 power. So in order to do this, what that means is 1 to the 1/6 power cis. Now it says you take theta divided by n. What is n in this problem? 6. So I'm going to take 90 divided by 6 plus 360k divided by 6. Okay? And that's going to be for k equals 1, 2, 3, 4, 5. All right? That's going to be all the different values that we get to find. What? Yeah, you have to find. You know what? I take that. It is 0. Sorry. I knew that was 0 on the page before. Change that to k equals 0. And this is the thing. If you're finding the 6 roots, you're actually going to find 6 of them. If you're finding the fourth roots, you're going to find 4 of them. If you're finding the fifth roots, you're going to find 5 of them.
It's always going to
Okay? It's always going to start with 0. Yep, and it's always going to be 1 less. And so now, 1 to the 1/6 is going to be 1. Sis, 90 divided by 6 is 15 plus 60k. So now what you're going to do is you're going to plug in 0 for k. So when I plug in 0 for k is 0, I get 1 cis, what? 15 degrees. That's your answer. When k is 1, I get 1 cis, because you have 15 plus 60, right? When k is 2, I have 15 plus, so I get 135, yep. When k is 3, I get 1 cis. 1 what? 95. When k is 4, I get 1 cis what? When k is 5, what do I get? 315. Now, you're going to notice, what do all these angles differ by? What do all those angles differ by? 60. So there you go. Okay. We're going to do another one. Find the fifth roots. Find the fifth roots. Can you say find them? It's not that hard once you plug them in. I'm not making an answer in rectangular form. So 4 root 3 minus 4i. That's going to be located over here, 4 root 3. And down 4. What's my hypotenuse here going to be? 8. It's a 30, 60, 90. What angle do I have here? It's 330 because this little angle here has to be 30 degrees. So to find the fifth roots, I end up having 8 cis 330, and I'm going to take that to the 1/5 power. So really what that means is that means 8 to the 1/5 cis. What am I going to do now? 330 divided by 5 plus 360k divided by 5. And I'm going to do k equals 0, 1, 2, 3, 4. 8 to the 1/5, I'm going to let you stay as 8 to the 1/5. I'm not even going to make you simplify that. Okay, sis, what's 330 divided by 5? 66. Plus, what is 72k? Okay. So when k is 0, I get 8 to the 1/5, cis 66. When k is 1, I get 8 to the 1/5, cis 138. When k is 2, I get 8 to the 1/5, cis 210. K is 3. $282. And last but not least, k equals 4, 8 to the 1/5, cis 354. Now just a little tidbit, you will never get an angle over 360. These are all going to be within 360. Okay, so if you did, you've done something wrong. Now this is what I need you to do. Okay, on page 577, you have 36 through 44, so those are 5 problems with De Moivre's theorem. Then what I need you to do for me is I have 3 problems on the roots, 47, 48, and 49. So you have a total of 8 problems. Add that to your existing assignment, and that will be due Monday.